Compound inequalities combine two inequalities with a logical operator. The operators are AND, which means the intersection of the two sets, or, which means the union of the two sets. In this video, we're going to translate everyday situations to compound inequalities. We're going to graph those inequalities on the number line and write them in interval notation and set builder notation. And we're also going to understand that sometimes the solution is all real numbers and sometimes there is no solution. It's the empty set. Suppose you're planning to buy a used car. When you search online, you see a place to enter a minimum price and a maximum price. You've decided on a maximum price of $10,000. You've also decided on a minimum price of $6,000. So your price range for this car you're going to buy is between $6,000 and $10,000. One way to write this as an inequality is to put the variable C, that stands for the price of the car, between the two values that are the maximum and the minimum. Since the price range is between $6,000, including $6,000, and $10,000, putting the variable in the middle represents that between idea. If we write the price range that we've decided on as two separate inequalities, we can see joining them into a compound inequality with AND or OR. If I graph the inequality C is less than or equal to 10,000 on the number line, I'm going to include 10,000 and shade numbers that are less than 10,000. If I graph the inequality C is greater than or equal to 6,000, I'm going to include 6,000 and shade numbers greater than 6,000. The price range between 6,000 and 10,000 is shaded both blue and red. The connector between the two inequalities is AND. To write this in interval notation, we write the blue interval and the red interval, and we connect them with the intersection operator, which is the same as AND in this case. The intersection of those two intervals is places where they are both true. And so that's the interval that we have between 6,000, including 6,000, up to 10,000, including 10,000. In set notation, we also connect the two sets with the intersection symbol, and the set that is the result can be written with that between notation where the cost of the car is between 6,000 and 10,000 inclusive. Suppose we were to join the two inequalities with OR instead of AND. Well, what that would mean is we're interested in parts of the number line that are shaded either blue or red. But that's the whole number line. All of the number line is shaded either blue or red or both. To write that, we would write the intervals. The OR symbol is the union, a U facing up, and the answer is the entire number line. So you can either write from minus infinity to infinity as an interval, or you can write a fancy R, which means all real numbers. All real numbers are solutions to the compound inequality that combines these two inequalities with OR. Just as the solution to a compound inequality might be all the real numbers, it can also be no real numbers, no solution. For example, if you want to buy a car that costs less than $5,000, but all the cars on the lot cost more than $8,000, you're not going to be able to find a car. If we shade the interval greater than $8,000, it's this red interval. If we shade the interval less than $5,000, it's this blue interval. If both of these inequalities need to be true at the same time, there is no solution. There are no cars on the lot that are less than 5,000, which is the most that you can afford. So the answer to this compound inequality is that there are no solutions, and we write that with the symbol empty set. No part of the line is shaded both blue and red. In summer 2018, the Delta fire burned over part of Interstate 5 in California. The highway was only open north of exit 718 and south of exit 689. The highway was open north of exit 718 and south of exit 689. On the number line, we can shade the part that's greater than 718 and the part that's less than 689. Notice that there is no overlap here. So even if in natural language we might say the highways open north of 718 and south of 689, in logical operations we need to use or here, because a car cannot be on both of those parts of the highway at the same time. And a number on the number line cannot make both inequalities true at the same time. So we connect with OR, and that's the union symbol. So the union of the two intervals doesn't really have any shorter way to write it. It's both these two intervals together. They have no overlap. So we would write the part of the highway that's open as minus infinity to 689, not including, union with 718, not included, to infinity.